Hello everyone, welcome back. This is Engineer Sam Wasapi. So in this video, we'll be looking at problems involving the properties of fluids. So before we begin, do not forget to like and subscribe to the channel. Alright, so we have our first problem which says calculate the specific weight, specific mass, specific volume, and the specific gravity of a liquid having a volume of 6 meter cubed and a weight of 44 kilonewtons. So to start with, we'll analyze the question and collect data. So in our data, what we can highlight is that we're being given in question the volume of the liquid. So the volume of the liquid is equal to 6 meter cubed, and we also have the weight of the liquid, which is about 44 kilonewtons. We have been asked to calculate the specific weight, so we need to find the specific weight, which we don't know at this point. We also need to find the specific mass, which is just symbolized as rho, which we don't have now. And we also need to find the specific volume that we don't have, and the specific what? Gravity. Alright, so to start with the information we have, what can we find? We can start by first looking for what is known as the specific weight. So let's find the specific weight. But what is the formula for specific weight? Specific weight is equal to the weight of the fluid divided by its volume. So it's a weight divided by volume. So what is the weight of the fluid? It is 44 kilonewtons. And what is the volume? 6 meter cubed. If we do our computation right, we'll have 7.33 kilonewtons per meter cubed. So this is our specific weight. Be mindful, the specific weight isn't the actual weight. The weight is 44 kilonewtons. Specific weight is just the weight that a fluid will occupy in a given space. Moving on to B, we can then calculate the specific mass. Specific mass, which is basically symbolized as rho. Now, how best can we find the specific mass? We can use the alternative formula for specific weight, which implies that specific weight is equal to rho g, which is the mass density times the gravity. Now, if we do our algebra right and make rho the subject of the formula, we'll have the specific mass to be equal to the specific weight divided by gravity. Now we need to take note that in this context, gravity is 9.81. That is if we're considering the fact that we need to assume that it's in a given value of newtons. So this is in newtons per kg. Now, the specific weight that we have in question isn't really the weight we need. So we need to find the specific weight that is in newtons in order to complement the gravity. So what are we going to do? So specific weight is equal to the specific weight we found, which is 7.33 times 1000 converts to newtons, and we have our specific weight to be equivalent to 7,333.33 newtons per kilograms. So with that in mind, we can now plug and chug. So now we're going to have 7,333.33 divided by gravity, which is 9.81. Therefore, our specific mass would then be equivalent to 747.54 kilograms per meter cubed. And that is our specific mass. Now let us find means of calculating what is known as our specific volume. Specific volume is equal to the volume of the fluid divided by the mass. So now how best can we find the mass? So we can say, by collecting a simple data, that mass is equal to rho v. Now this is coming from the context where we're saying that the specific mass is equal to mass over volume, because specific mass is just mass density. And if we put in context of the idea of density, or we say mass or volume, we can use the same idea to come up with star. So having this, we can say that mass is equal to rho, which was found to be 747.54 times 6. And this will give us about 4,485.22 kilograms. And this is our mass. Having the mass, we can then say that the specific volume is now equal to, we said, volume of the fluid divided by the mass. And the volume is 6 now divided by its mass, which is 4485.22, will give us about 1.34 by 10 to the minus 3 meter cubed per kilograms. So that is basically our specific volume. And in the end, we've been asked to find our specific gravity. Now, specific gravity is equal to the specific weight of the fluid that is being studied, which is what we are finding here. In the first portion of the solution, we found our specific weight here of the fluid we're studying to be 7.33. So we're going to say the specific weight of the fluid we're studying, which is having 7.33. Now we need to convert this, since it's in kilonewtons, to newtons by 1000 divided by the specific weight of water, which is a standard value of 9810. That is in newtons. So if we compute this, we end up having our value of the specific gravity to be about 0.75. And that is our specific gravity. Alright, so in the next problem, we've been told to calculate the density, specific weight, and weight of 1 liter of petrol of specific gravity 0.7. So here, if we collect our data, we need to understand the specific gravity of petrol given in question is about 0.7. We've been told that the volume is 1 liter. Now, we need to know that 1 liter is basically equivalent to 10 to the minus 3 meter cubed. So with what we have, what can we find? We can find the first thing, which is the specific weight. Let us find this specific weight. So now, with what we have, what do we have to do? We can use the formula for specific gravity. Remember, specific gravity is equivalent to the specific weight of the fluid that you're studying divided by the specific weight of water. Now, to find the specific weight, all we have to do is cross multiply this, and you have the specific weight being equal to specific gravity, that is of petrol, multiplied by the specific weight of water. And this is giving us 0.7 multiplied by 9810, which will give us about the specific weight of 6867 newtons per meter cubed. With this in mind, we can now see to it that we find another value. And what is it that we need to find now? Let us see to it that we find the weight of this particular fluid. Now, we need to understand that the specific weight is equal to weight of the fluid divided by the volume of the fluid. In our question, we haven't just been asked to find the specific weight, but as well as the weight of the particular fluid, the actual weight. So for us to find the actual weight, we'll also do a cross multiplication here, and we'll say the actual weight, which is the weight of the fluid, is equal to specific weight multiplied by the volume of the fluid. And the specific weight that we did find earlier on was about 6,867. Now, having this being multiplied by 10 to the minus 3, we end up having a value of the weight being equal to 6.87 newtons. So that is basically weight of the fluid. Then we also need to find the density rather, of the particular sample that we have. So now, how best can we find the density? Now, the density that I'm really talking about is the mass density of the fluid. So we know that specific weight is equal to rho g. So to find rho, we have to create an algebraic way of making rho the subject of the formula. So we say rho is equal to specific weight divided by gravity. And we know that the specific weight that we found was 6,867 divided by gravity is about 9.81. And this is equal to 700 kilograms per meter cubed. Now, I know some of you might be confused about the gravities I'm using. There is a gravity of 9810. That is not really the gravity that we mostly just use as the standard. That's the gravity of the standard liquid, which is of water. But in this context here, this gravity is just a normal gravity we all know, which is 9.81. So be mindful about the difference of these two types of gravities. There's a gravity of the standard fluid, which is water, and just a usual gravity. All right. Now, the last thing I need you to understand is that the specific gravity can tell you a lot about the fluid that you're studying. So take note of this. If the specific gravity is equal to 1, then the fluid that you're studying is basically water. If the specific gravity is less than 1, then the fluid you're studying is lighter than water. Then, if the specific gravity is greater than 1, then the fluid is heavier than water. Just like that. These are just basic things you have to know about the specific gravity. Alright, thanks for watching. If you have any queries, you can reach out to me on WhatsApp on the line +260 77 149 5252. Remember, slow progress is better than no progress. And I said the jazz for becoming a statistic. Let's try and push for that A+.